Okay, we're here with Luke to talk about polynomial operations. Are you ready, Luke?
Yeah.
Okay, so let's first talk about what operations are. Operations are things like add, subtract, multiply, and divide. And polynomial, I'll explain in just a second. But before we do that, let's first review something called the distributive property. You might remember what the distributive property is. It has to do with things like this, where you have a variable or a number outside the parentheses, and then you have more than one term inside the parentheses. And do you remember what you do with that?
Yeah, you multiply the variable outside the parentheses by both of the terms inside.
Exactly. So you're going to multiply that x times the 2x and then the x times the plus 3. And the reason it's called the distributive property is because you're kind of distributing that x to both of the terms inside the parentheses. Kind of like if you were at a picnic and you had some cookies and you were handing out cookies to everybody, you're distributing cookies to each person. That x gets distributed to each term. So if you did that, what would the result be?
It would be 2x squared plus 3x.
Yep, because you would first say that's x times 2x plus x times 3. And then when you simplify that, you get 2x squared plus 3x. Well, the interesting thing is when you do polynomial operations, you're really just doing the distributive property in a little bit more of a complicated way. So let's take a look at over here. Here we have the same thing inside the second parentheses, 2x plus 3, same as the thing is over here. But instead of just x on the outside, we have this x minus 4. And when we have a situation like that, the thing you have to remember is that you're going to distribute not just the x to the 2x plus 3, but also the minus 4. So it's going to look like that. You're going to distribute both the x and the 4 to both terms that are inside the parentheses. And it's really important to remember that you have to look at the signs. So that x you're distributing across, but that 4 is a minus. So you're going to take the minus 4 and times it by the 2x and the minus 4 and times it by the 3. Does that make sense?
Yeah.
Okay, so what would we get if we did that?
You would get 2x squared plus 3x minus 8x minus 12.
Yep, and you've done the math in your head really well there. You first get all of these terms like x times the 2x, which you rightly noted is 2x squared, and then you went through the other terms here too. And so you get to what you just said, 2x squared plus 3x minus 8x minus 12. Can you simplify that any further?
Yeah, you can make it 2x squared plus 3x minus 8x. You can combine those to make it minus 5x.
That's exactly right, because those are like terms. They're both x terms. So you get to this right here, 2x squared minus 5x minus 12. So what you've done, and I'll put this up here, is that you've taken two binomials to get a trinomial. So let's go and look at that vocabulary here. A binomial is something that has two terms, like a bicycle has two wheels. So this x minus 4, that's a binomial. The 2x plus 3, that's also a binomial. And what you have down here is a trinomial because it has three terms, just like a tricycle has three wheels. And a polynomial is just a way to say something with multiple terms. Nomial, the root there, nom, if you speak Spanish, you might know nombre means name. Nom is also a French word that means name. Basically, anything that you would name in math, like a term, is what a nomial is. So polynomial just means multiple terms. Binomial means 2. Trinomial means 3. Does that make sense to you?
Yeah.
Okay. Now that you know how to do this, you're basically taking the distributive property and you're using it with binomials to get trinomials. You can do it with even larger polynomials. So here you have ax plus 7. What is that? A binomial or a
A
trinomial?
binomial.
That's right. And then you have 3x squared minus 2x plus 2. That's what?
A trinomial.
A trinomial. And how would you do this one?
You would multiply ax times 3x squared and then minus 2x and then plus 2 and then do that with 7 as well.
Yep, exactly right. So now that you know how to do this, you could do it with a trinomial times a trinomial, right?
Yeah.
Or even larger ones. And so now you know how to do polynomial operations. Now there are a couple special cases that I really want you to understand because they can really help you to see patterns that can make you understand it and do the math even more quickly. So the first is called the difference of squares. Now I'll get to why it's called the difference of squares in just a second, but let's look at this example here. You have x minus 4, a binomial, times x plus 4, which is also a binomial. Now, how would you go ahead and multiply this out?
You would do x squared minus 4x plus 4x and then minus 16.
That's right. So we would just do the same distribution there. And as you say, you have x times x, which is going to be x squared. And then you would go through those terms, and you would have x squared plus 4x minus 4x minus 16. Now, can you simplify that further?
Yes, you can remove the 4x. The positive 4x and the negative 4x would cancel out.
That's right. Isn't that interesting? So what happens here is when you have a variable minus a number and then that same variable plus a number in those two binomials, those are always going to cancel out. And what you have here is called the difference of squares. Now, what does that mean? A difference is minus, and can you see how x squared is a perfect square?
Yeah.
Because it's x times x. How about 16?
Yeah, it's 4 times 4.
That's exactly right. So you have a difference of two squares, x squared and 16, and the difference is one minus the other. So when you have this pattern of something minus, something plus, and if those two things are the same, then you're going to get this difference of squares. And so that's a really useful one to be able to recognize, and you can do it really quickly. Another one is the perfect square trinomial. So in a perfect square trinomial, you have something that looks like this. You have x plus 4 times x plus 4. Now that's the same thing, but multiplied by itself. So you could also write it like x plus 4 as x plus 4 squared. Do you see how that works?
Yeah.
Okay. So when you multiply this out, how would you do it?
You would do x squared plus 4x plus 4x plus 16.
That's exactly right. Now, can you simplify that one?
You could combine the two 4x's into 8x.
Yep, exactly right. So you have x squared plus 8x plus 16. Now, let's look at some patterns here. What would you say about that 8 and the 16?
Well, you could say that 4x or 4, two 4's add to 8, but 4 times 4 equals 16.
That's right. These two patterns, difference of squares and perfect square trinomials, are great examples of how you can recognize patterns when you're doing polynomial operations. And when those patterns don't exist, you can always just follow the rules and distribute across. Does that make sense?
Yeah.
Great. Good job.